system gets attacked and so on and so forth, right? There's an autoimmune disease, you know, like big classes, okay? Autoimmune on one side, your immune system is too active and attacks your healthy body, not active enough, cancer, okay? So the, at least, you know, on the, never mind, on the, there is a specific branch, okay? You know, like it's the, okay, so FDA, so you know, Chinese immigrants, you know, brought this snake oil and this belief that it, you know, is against arthritis, and you know, obviously, you know, the railroad workers had a lot of joint pain and so on, not necessarily arthritis, okay, but the problem was, so it became very popular, but the problem was, it was poisonous, okay, so people started dying, okay, and that's basically like, you know, why, you know, the government said like, okay, well, we have to do something about this, okay, and that's why the FDA exists. The FDA exists primarily, so because the problem is that I can make $1 billion business tomorrow, no problem, right? I can make a sugar pill and tell you it makes you healthy, okay? I can tell you it cures cancer. I can tell you, you know, you're gonna live at least until 80, whatever, okay? I'm just making this up, okay? But you're not a medical professional, okay? I, you know, come from a university, right? You believe me, right? Well, that's a problem, right? Okay, and there is billions of dollars of health fraud industry out there. Okay, so and there is not even close to enough resources for any regulatory agency to actually like keep that out of the market. Okay. But on the grand scale, yes. So, but the primary concern of what they're trying to go after is if it kills people, if it's unsafe, okay? Health fraud, that you're claiming something that is not true, okay, is also a big issue, okay? But it depends sort of on the scale. But they don't actually have enough resources to actually follow all of that up, okay? So, for example, this tells you something else. If you Google something about health, okay, on the internet, right? Unless you start to go into the scientific reality of it and, you know, ultimately the totality of scientific evidence, you can't know if it's true or not, okay? Now you have different levels of resources, so, you know, again, we talked about this credibility of resources, right? It's very important to judge, you know, where the information comes from. So scientific journals, yeah, well, at least they're peer-reviewed, like some other expert in the field, actually two other experts in the field, usually sometimes more, have to read it before it makes it into the paper. But we all know the stories, like, you know, a guy in Korea, whatever, you know, that is not a guarantee to keep it out of that, right? You used the annual reports of companies, right, from the SEC, right? They're reliable information because, pretty reliable information, because if people do the numbers wrong, and there's a lot of people who look at those numbers, okay, well then people go to jail, right? So therefore there's an incentive to not lie on these things, okay, right? You can, and that in the US, for example, it's pretty reliable, okay, right? So, you know, so there are different sources, you know, of different sort of credibility, and, you know, and how you can rely on them, right? And the FDA is a good source because, you know, that is what they do, okay? So let's have a look at, so there is this classification system, right? So description of each class of device, right? So we have anesthesiology, cardiovascular, chemistry, dental, ear, nose, and so on, okay? So, and these are the parts of the 21 CFR. Remember I told you 21 CFR is the code of all federal regulations, right? So, let's see. Which one do we have? Huh? Neurology. Is it neurology? Or toxicology, radiology? So you would pick the best one. Orthopedic, no. Yeah, okay, so radiology. Okay, so so now we're looking at CFR 21, part 882. Okay. Now, neurological diagnostic devices, neurological surgical devices, neurological therapeutic devices. Okay, so we want to look at neurological therapeutic devices. biofeedback device. Okay, here we go. Paragraph 882.5.5050, right? Okay, so this is the relevant legal part for this, okay? So identification. A biofeedback device is an instrument that provides a visual or auditory signal corresponding to the status of one or more of the patient's physiological parameters, for example, brain wave, alpha wave activity, muscle activity, skin temperature, etc., so that the patient can control voluntarily the physiological parameters. Okay, so now you actually have a pretty concise definition of, and this is not like, you know, a new thing or something. There's lots and lots and lots of evidence. If it makes it into this is again a very high level legal, you know, like definite, you know, thing, right? So, you know, lots of stuff has to be done to make it there. Classification. So it's a. This is one thing you have to remember. It's a Class 2 medical device. Okay, special controls. The device is exempt from the pre-market notification procedures in subpart E of Part 807 in this chapter, when it is a prescription battery-powered device that is indicated for relaxation training and muscle re-education, and prescription use. Okay. Now, you still have to look a little bit deeper. Okay, in terms of this, where because what matters a great deal is the context of these medical devices. Okay, what is it that you're really trying to do? So if it's just from muscle re-education, that's one thing. Okay, muscle re-education in order to re-establish neurological activity after a stroke is another. I don't think that's the same thing. Okay, but you have to look into those details. You know, you got it. So. But anyway, so it's a Class 2 special device. You know, like this is a Class 2 special device, which is a, but it's a neurological therapeutic device, so it might be okay, right? There's a Class 2 device, which is now here it's like it's exempt from pre-market notification. What does that mean?
Pre-market notification, when you launch some new product to the market, you have to very carefully to look for the first feedback and send this report to the FDA.
Right.
To see if it's really safe and effective.
Yes.
It's a very limited market launch on the very, very precise control.
Right. So, you know, there's, and you know, like one has to, and I'm not an expert at this, okay? There is pre-market notification and there's pre-market approval. Right? Pre-market approval means the FDA has to approve the device that you can actually sell. You're not allowed to sell it beforehand. I think for a Class 1 medical device, that's usually the case, right? Notification might be, well, the FDA, you notify them when you bring it to market, they can object to it. They have a record, okay, or there's a certain period. I don't know, you have to look up the regulation about this, okay? But it doesn't really, but you can't sort of like, you don't lose time by them reviewing, you know, the case, like, you know, in the patent case, okay? Let's see, generally in the medical space there's other places like the Institute of Medicine, that's like the highest authority sort of on all medicine, okay, which basically is even above the government, you know, which is like the Academy of Sciences version in medicine. So let's see, in this space, so the general sort of thing is, in medical space, is so there is this phrase called totality of scientific evidence.
Okay, yeah. We have a big group and we are from different cities, so we would like someone have a train right now.
Oh yeah.
May we go?
No problem. Yeah, of course. You don't have to ask. It's just like it's all open. Yeah.
And what a great pleasure to meet you here.
Likewise. Thank you. Yeah, this is just, you know, like basically an open workshop session, you know, for anybody who. So you know, so you can find all sorts of ways of like how is totality of evidence. This is a very standard phrase. How is that actually done, right? Let's see. No, it's like for evidence, this is like the standard, you know, because everything in biology, basically. So, you know, so this is actually, I want to get to another thing. Like, there is also guidance to industry, okay? Like, that's very useful from the FDA, right? So there's all this regulatory stuff, okay? And they're actually very good in explaining to industry, okay, what it is, if you want to bring a product to market and so on, you know, what it is that the criterion that you need to fulfill, how you're going to do it, and so on and so forth. Like, let me give you actually one guidance to industry. Just because I happen to know this one relatively well, mobile. Okay, FDA guidance to industry for mobile. This is a relatively recent one. Okay, and there's dozens of these, right? So if you want to make a mobile app, right? Okay, heart rate monitor, biofeedback monitor on the phone. Yeah, oh, seriously, okay, right? So can you just like make an app, okay, and just put it on Android phone? Okay, you're not like doing anything medical per se, okay? Is that? Well, what's the issue there? What's, you know, like, how do we deal with that regulation? You know, so it actually turns out there is regulation. So the guiding principle, I just happen to know where this is, okay, this is generally the case in medical space, yeah, I just happen to remember which page this is on. So the intended use of a mobile app determines whether it meets the definition of a device. Okay, it's the intended app, not just the actual use, but the intended as stated in 21 CFR 8014. Intended use may be shown as labeling claims, advertising material, or oral or written statements by manufacturers or their representatives. So it's pretty broad, right? When the intended, this is a really important sentence, not just for mobile apps, for you know, FDA stuff in general. When the intended use of a mobile app, in this case, for everything, is a diagnosis of disease. It's always the same, but this is core wording, okay? It's a diagnosis of disease or other conditions, or the cure, mitigation, treatment, or prevention of disease, or, and this is where it becomes more general, is intended to affect structure of any function of the body of man, then it is a medical device, right? And he gives a nice little example here. So one example is the mobile app that makes light emitting. So mobile app that makes a light emitting diode operate. Okay, so on your phone, the thing. Okay, everybody has that, right? You have a mobile app that when you switch it on, the light emitting diode operates. Okay? If the manufacturer intends the system to illuminate objects generally, are you late night at home trying to get into the door, you know, drop your keys, that sort of thing, right? Then without a specific medical device intended use, the mobile app would not be considered a medical device. If, however, through marketing, labeling, and the circumstances surrounding the distribution, the mobile app is promoted by the manufacturer for use as a light source for doctors to examine patients. It might be the same LED, the same, you know, software, okay? Then the intended use of the light source would be similar to the conventional device, such as an ophthalmoscope. Okay? Right? So whenever you cross into this space, again, this is just, I mean, for the medical space, it's very significant. Okay? For some other spaces, it may, like, it's not just the regulation of it and just getting, the regulation isn't there to get by it. Okay? You have to, like, really work in the space and implementation, but you can also, just like from the patents are implementation in terms of the actual claims that we talked about, okay? But there's obviously lots of technical information there as well, okay? Here, you also have lots of technical information that really underpins this regulation, okay? The FDA is very scientific. So understanding this, okay, is actually another way of understanding the synthesis of a lot of knowledge out there, right? So when you want to understand, so let me give you an example. Vitamin D, right? Which, here, less sun becomes a bit of an issue in the winter, right? We know very well about the role of vitamin D in bone growth, okay? Everybody knows. Fine, that's reasonably well understood. And that's renal DNA and all that stuff. Okay. In the 1990s sometimes, I think, science discovered that the functional active form of vitamin D, which is a dehydroxy form, is involved in the transcription process of genes, okay, or translation to RNA. Or, I don't remember exactly, but it's basically a core, like in the core transcription process, sort of mitosis, of cell division, right? It's involved in that, okay, right? And we didn't know this before, okay. So they're like, okay, well, that obviously can have some implications. Did we actually get those things right? And so then there were lots of studies, okay, big clinical trials, okay. I mean, we're talking huge stuff in all sorts of fields, okay. And it was linked to multiple sclerosis, okay, autoimmune disease, all sorts of autoimmune diseases, cancer, and so on and so forth, okay, right? And these things sort of like bubbled up. We're talking about billions, probably, well, maybe hundreds of millions of dollars worth of, like studies, okay, right? And in the US, this sort of caught on because all the doctors started to be aware of this, okay? And they basically said, like you shouldn't take a little bit more vitamin D, okay? The next doctor said, and the next doctor said, and so on and so forth, right? So it's like a wave, going sort of across the country, okay? Basically, sort of by a certain automation to, declaring the population vitamin D deficient, okay, right? The current recommendations on vitamin D intake are not accurate because we have this new scientific knowledge that's involved in other significant things other than just, what we thought before, which is, the bone metabolism and so on, okay? And like this was obviously, the press part, the media played its role in this, but like it was literally, if you asked, thousands of doctors, okay, they would have said that, okay, right? Now at some point, this got to a point where the U.S. government and the Canadian government both went to the Institute of Medicine, which is the highest medical body, and they sort of actually make those recommendations and said, what's in it? I mean, like, do we have to, like, come on, you guys, do we have to adjust the recommendations, And so and actually I'll pull this up, it's kind of nice. This is what I mean by totality of scientific evidence. So, this one. (2010) kind of would assume so. So this one has to look. Might take a little while. Okay, so they looked at this, okay, and they looked at the totality of scientific evidence, okay. Now, the country already had adopted a different standard, so, everybody it's like, oh, vitamin D deficient, okay. So this is 1,100 pages long, this report, okay. But what we mean by totality of scientific evidence, okay, is Let me see. So I can't, you know, like there's a certain structure to this. But anyway, like if you go through this, right, and you look at like the studies that they looked at, okay, and they consider in their evidence, thousands, okay, of studies, okay, of clinical trials, right? And in the end, funnily enough, let's see if we can find the overview. Okay, let's do a summary. Okay, calcium and vitamin D are undoubtedly essential for during the past 10 years. So this was 2010. So you know, started maybe that was a bit early, like 2000 or so. There has been increasing interest in the possibility of enhanced roles for vitamin D in human health. A number of researchers in the scientific community have suggested relationships, and this is modest, you know, relationships between vitamin D intake and health outcomes ranging from cancer prevention to increased immunity. Others have suggested possible roles in preventing diabetes or preeclampsia during pregnancy. The media have also taken an interest and public expectations have been raised. At the same time, physicians have been ordering blood tests that seem to suggest, based on use of criteria that have yet to be validated, that many in the North American population are vitamin D deficient. For calcium, there is a concern that